So let's look at evaluating definite integrals using the technique of substitution. So here's our integral between the terminals 0 and 1 of the integrand 5x plus 3 over 3x plus 1 to the power of 3 with respect to x. Okay, so what we're going to do is we're going to let our substitution be u equals 3x plus 1. du dx will be 3, so that implies that du is 3 times dx. Okay, and then what we're going to do is rearrange this to get x by itself. So we'll take our substitution, u equals 3x plus 1. Let's rearrange it and try and get x by itself and see if we can perhaps substitute that into the top or do something with the denominator, with the numerator there, sorry, do something with the numerator. We've already substituted for the denominator, u equals 3x plus 1. Okay, so let's rearrange this. So subtract 1 from both sides, u minus 1, divide by 3, we're left with x. And then we could write 5x plus 3 as being 5 on 3, because there's the 3 underneath, times u minus 1 in parentheses, plus our 3 on the end. Okay, now, all right, well, maybe that'll help us work out what the terminals are. All right, now, at x equals 0, because one of the terminals, the lower terminal, is x equals 0, at x equals 0, we find that x equals 0, u is equal to 1. 3 times 0 is 0, plus 1, u is 1. At x equals 1, we have 3 times 1 is 3, plus 1 is 4, so u is 4. Okay, let's have a look at our integral now. So the integral 0 to 1, 5x plus 3 on 3x plus 1 to the power of 3 dx is 1 on 3, okay, 1 on 3 times 1 on u cubed, okay, u cubed, and then the 5x plus 3 is replaced by 5 on 3 u minus 1 plus 3. Okay, the reason we have the 1 on 3 there is that the du has 3 times dx, whereas we only have dx. So that factor 1/3 removes that. And so that this object here, just ignoring the terminals for the moment, but this object here, the integrand, including the factor 1 on 3 out there, is identical to this. Okay, you could, if you reverse the substitution, it'll take you right back to this. Okay, but we have to, now that we've expressed the integrand in terms of the variable u, we need to integrate, the terminals need to be in terms of the values of u at x equals 0 and x equals 1. All right, so u equals 1, u equals 4. Okay, well, one thing we could do, let's multiply through by the 1 on u cubed, expand out the parentheses here, do all that in one hit. We're left with 5u on 3u cubed minus 5 on 3u cubed plus 3 on u cubed. And tidying that up a bit, we'll have the factor of 1 on 3 outside, the integral 1 to 4, sorry, 5 on 3u squared minus 5 on 3u cubed plus 3 on u cubed du. Okay, now they're much easier to integrate. I mean, we can take these upstairs to make it more obvious, but these, as an expression, this is much easier to integrate than what we had before, which was the integrand here, which was a rational function, having a polynomial on top and one underneath. So, what we now have is 5u to the minus 2 on 3 minus 5u to the minus 3 on 3 plus 3u to the minus 3 integrated with respect to u. When we do that, we increase the powers by 1. So what we have here is u to the minus 1, okay, divide minus 1, so that makes this term now negative. U to the minus 2 divided by minus 2, so that becomes the negative and negative becomes positive, and 2 3s are 6. Okay, and then u to the minus 2 divided by minus 2, which makes this term negative as well. Now we need to evaluate between the terminals. So we perhaps just tidy this up a bit if you like, just take the u's downstairs again, drop them under the minus 5 on 3u plus 5 on 6u squared minus 3 on 2u squared. Now evaluate between u equals 4 and u equals 1, so replacing the u's with 4 in the first set of parentheses minus replacing the u's with the 1 in the second parentheses. Okay, tidying that up all in one hit gives us minus 11 on 24 minus 2 1/3. Okay, and tidying that up again, we end up with 1 7/8 times the 1/3 out front, which gives us 5 on 8, or 0.625 if we want. All right, that's it.